Hello students, good evening students. Previously we discussed complex compounds IUPAC nomenclature with few examples. Complex compound continuation topic here. Werner's theory of complex compounds. Complex compound, next topic is Werner's theory of complex compound. What is this theory telling? You know that in the complex compound central metal atom is present. That metal is surrounded by n number of ligands. That is the complex compound. One simple example for a complex compound, CONH3 6 times Cl3, cobalt complex it is. The metal central metal atom here the cobalt. So Werner's theory basically tells that in the complex compound metal atom, central metal atom have two types of valencies. One is primary valency and another one is secondary valency. This Werner's theory of complex compound mainly focus on central metal atom valencies simply. So according to Werner's theory, this central metal atom have two types of valencies. Central metal atom have two types of valencies, that is primary valency and another one is secondary valency. Secondary valency. What is primary valency? What is secondary valency of the central metal atom? Primary valency indicates oxidation state. Oxidation state of the central metal atom. Central metal atom. Oxidation state of the central metal atom. And the secondary valency indicates coordination number. Coordination number of the central atom. Number of the central metal atom. So in the every complex compound, central metal atom having the oxidation state and around the central atom n number of ligands are present. So what is the primary valence indicates oxidation state of the central metal atom. Secondary valence indicate coordination number of the central metal atom. What is the coordination number? Coordination number is nothing but number of ligands. Coordination number is nothing but number of ligands around the central metal atom. For example, octahedral complex. Octahedral complex. Octahedral complex means around the central metal atom 6 ligands are present. Here the central metal atom, the ligand, coordinate covalent bond, coordinate covalent bond. Here the coordinate covalent bond representation, arrow mark representation around the central metal atom. Here the ligand. So around the central metal atom 6 ligands are present. Coordination number of the metal atom is 6. Coordination number means the number of ligands around the central atom. So here, based on this complex, what is the metal oxidation state and what is the primary valency? Oxidation state is nothing but primary valency. What is the secondary valency? Secondary valency appears here. Secondary valency is nothing but 6 and primary valency is depends upon the ionic sphere. What is the ion is present in the ionic sphere. Here observed here, this is -1 and the -3. On the ionic sphere -3, complex sphere charge is +3. Amine is the neutral ligand, you know that. So neutral ligand charge is 0. So the whole charge is nothing but metal charge, that is +3. So in this complex, primary valency of the cobalt is +3, secondary valency is the 6. Number of ligands are 6. So this complex, general representation of this complex is CO 6NH3 Cl3. This is represent like this. CONH3 6NH3 Cl3. This is nothing but this complex. So one more complex, just look at another complex, another example. What is the primary valency of the central metal atom? What is the secondary valency of the central metal atom? Here in this area, both NEET students as well as JEE students, one important reaction is there. based on representation like this. That reaction is reaction with silver nitrate solution. What is going on? If representation is like this, reaction with silver nitrate, the resulting compound, the resulting precipitation is possible or not, we are discussing after this explanation. This is both NEET and JEE students, that area is important. Now observe here students, I given here the three complexes. In these three complexes, what is the central metal atom primary valency and what is the secondary valency of the central metal atom? So primary valency, what I said, oxidation state. Secondary valency is coordination number. Observe here, in the complex sphere, which ligands are present? Amine is 5 and Cl is 1. So secondary valency here the 6. What is the primary valency of this complex? Primary valency depends upon the ionic sphere, what are the ions are present outside. Here the Cl is present, number of Cls are 2, here the -2, here the +2. The whole charge on the complex sphere is the sum of the metal and ligand charges. Amine is the neutral ligand, Cl is the negative ligand, -1. For balancing +2, here the cobalt is +3. So +3, primary valency is the +3. This complex, as per the Werner's representation, one notation is there. So basically primary valency, secondary valency represented like a thick lines like this, and the primary valency represented like a dotted lines like this. This is the secondary valency representation between metal and a ligand. This is the primary valency representation between metal and ionic sphere, what are the ions are present. Now I am representing, observed here, CO is a representation, 6 ligands are present, NH3, 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 NH3 and Cl. And one more important point here, this Cl act as not a secondary valency, and also it is balancing the primary valency also. Reason, oxidation state of the central metal atom not only depends on what are the ions are present outside, and also depends on the Cl because of the charge. So this Cl satisfying the primary valency as well as secondary valency. So this Cl representation with secondary valency as well as primary valency like this. Remaining how many Cls are present outside? 2 Cls are present. The 2 Cls represented with anywhere like this, anywhere. There is no specific position for the primary valency, but secondary valency has the specific positions around the central metal atom. Next to this complex, observed here. So here the number of ligands inside 6 are present. So secondary valency is 6. Secondary valency is 6. Primary valency, check that oxidation state of the central metal atom. Here the Cl minus, here the +1. Amine is a neutral ligand. 2 Cls are present, -2. Here for getting +1, cobalt is +3. So primary valency is the +3. So central metal atom is the cobalt. Around the cobalt, 6 ligands are present, represented with a thick line like this. So NH3, 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 NH3. 4 amines are there. Remaining 2 Cls, Cl, Cl. But these 2 Cls not only balancing the secondary valencies, and also these are balancing the primary valencies. So represented with the dotted line also, dotted line. So observed here, secondary valency has a particular position, but primary valency there is no position. Anywhere you represent, anywhere is the second primary valency. This is the representation of the complex as per the Werner's theory. Cobalt, that means metal having the 2 types of valencies representation. Next, observed here, outside nothing is there. So complex charge is 0. Here the 0, this is -3. This is plus 3. So secondary valency is 6. Primary valency is plus 3. Complex representation, around the metal atom 6 ligands are present, 3 amines and 3 CLs. Cl, Cl, Cl. This is 3 Cl satisfying the primary valency also represent like this. So this is the representation of the complex compounds as per the Werner's theory, primary valency, secondary valency identification. Here these ligands are monodentate ligands. If in case bidentate ligands are present, how to represent? How to identify the primary valency, how to identify the secondary valency, that is important for NEET and JEE students. For both NEET and JEE students, look at those examples also. Okay, now students, few more examples we'll discuss. Now, here few more examples, students. Identify the primary and secondary valency of the complex cobalt central metal atom. Here the -3 is present, here the +3, whole charge is the +3. En means ethane 1,2-diamine, ethylene 1,2-ethylene diamine. That is the neutral ligand. Charge is 0. So cobalt charge is +3. Ethylene diamine, ethane 1,2-diamine, IUPAC name is you know that is the bidentate ligand. First of all, bidentate ligand, 2 donor atoms are having. How many are present here? 3. Each one having 2 donor atoms. 2 into 3, 6. Coordination number is how much? 6. So secondary valency is 6. And the primary valency how much of charge here? +3. Next here, this is -1, either +1. Here the -2, here the 0. Forgetting +1, how much of charge is needed? Cobalt +3. So primary valency is +3. Secondary valency, 2 Cls are present. Each ethylene diamine having 2 donor atoms. Here the 4, 2. Secondary valency is 6. Secondary valency is 6. Primary valency is the +3 here. Next, observed here. The charge, how much they mentioned? -3. Here the different. OX means oxalato, negative ligand. It is a bidentate ligand here. C2O4 -2. You have idea? Oxalic acid, H2C2O4. Oxalic acid is the diprotic acid. After releasing 2 H+ ions, oxalate ion is generating C2O4 -2. The charge is -2 here. So oxalato. So each oxalato having the -2, here the 2 oxalate ions are present, total -4. Cl is -1, here the -2. Forgetting -3, chromium has how much of charge? +3. So oxalato ion is the bidentate ligand. First of all, bidentate ligand, because of 2 donor atoms are present in that. COOH. After releasing H+ ion, oxygen gets negative charge, oxygen gets negative charge. That is bidentate. Now observe this complex representation, how it is existing. So around the metal atom, 6 ligands, how they are connecting. Ethane 1,2-diamine structure, you know that before. Nitrogen connected with CH2 representation. Nitrogen connected like this. Simple way of representation I am representing. Nitrogen connectivity. Nitrogen connectivity. Here around the cobalt, 6 ligands are present. That indicates the secondary valency. Cobalt oxidation state is +3. That is the primary valency. This is the representation of this complex. So outside, how many Cls are present? 3 Cls. Anywhere represent like a primary valency like this. Next, this complex cobalt connected with 3 metals. Cobalt connected with 6 ligands. Here I am representing 1 ligand, with bidentate ligand. This is another bidentate ligand. 2 Cls are present, Cl, Cl. These 2 Cls balance the primary valency as well as secondary valency. One is outside is present, that is represent anywhere. There is no specific position for the primary valency. This is the representation of this complex as per the Werner's theory. Next, observed here, chromium, oxalate, both the donor atoms are oxygen, both the donor atoms. This is the representation. O, C double bond O, C double bond O, represent like that. O, C double bond O, C double bond O. Next here, Cl is present. This is Cl, balance the primary valency as well as secondary valency. So this is the representation of Werner's theory for bidentate ligands. Okay. Now one important point we are discussing now. That is precipitate formation or reaction with the silver nitrate, the complex. Look at that also. Students, reaction with silver nitrate. This is important for both NEET as well as mains students. Reaction with the silver nitrate solution. For example, the complex is present CO6NH3 Cl3 existing like that. This complex is reacting with the silver nitrate solution. The product is how many moles of silver chloride precipitate is forms. That is the question. How many moles of silver chloride precipitate is forms. How many moles of silver chloride precipitate is forms depends on, remember this, depends on number of Cl ions in ionic sphere. Number of Cl ions present in ionic sphere, not in the complex sphere. This complex representation CONH3 6 times Cl3 we are representing like that. The Cl ions which are present in the ionic sphere, they are reactive. In the complex sphere, they are not reactive because of their ligands, their coordinate covalent bond is existing with the metal atom. So here the silver nitrate is reacting. How many Cls are present here? 3 Cls. So how many moles of AgCl formation? 3 moles of AgCl formation taking place. But another important point here, 3 Cls required how many moles of silver nitrate? 3 moles of silver nitrate. That is important for the exam. Another complex compound I am taking here, CO5NH3 Cl3 silver nitrate solution. Then how many moles of silver chloride precipitate is forms? Number of moles of silver chloride precipitate formation depends on number of Cl minus ions in ionic sphere. Don't forget that. So this complex representation CONH3 5 times. We need to balance the 6 ligands. Amines, how many are present? 5 are present. So 1 chlorine is included in the complex sphere. 1 chlorine is including in complex pair, 2 chlorines present outside. So 2 moles of silver nitrate solution is needed. Then 2 moles of AgCl is forming precipitate. This is important. This is NCERT based concept for both NEET as well as mains student is important. Moles of the silver nitrate. Sometimes they are asking how much amount of the silver also, because of 3 chlorines react with 3 moles. 3 chlorines react with 3 moles, 6 AgCl. 1 chlorine reacting with 1 AgNO3, how much amount? 1 mole of AgCl. So amount based, grams based question also possible for mains as well as NEET students. Okay students, the next we are discussing next concept in next video. Bye students. Okay students, we are discussing next concept in next video. Bye students.